Kathmandu, the bustling capital of Nepal, is a city of contrasts. Ancient temples stand tall alongside modern buildings. Narrow, winding streets are filled with a vibrant mix of people and vehicles. But one thing remains constant. Kathmandu needs a reliable power supply. The city's existing electrical grid, a network of overhead wires, is outdated and struggling to keep up with growing demand. Power outages are common. This puts a strain on businesses and disrupts daily life for residents. It's clear Kathmandu needs a power upgrade. The city's aging electrical infrastructure is not just an eyesore, it's a real problem. Tangled wires pose safety hazards. They are also vulnerable to damage from wind, rain, and earthquakes, which are all too common in this region. Kathmandu's residents deserve better. They deserve a reliable and safe power grid, one that can support the city's growth and development for years to come. Underground electrical cabling offers a modern solution to Kathmandu's power woes. Instead of relying on overhead wires, power cables are buried underground. This simple change brings big benefits. First, it improves safety. No more exposed wires mean less risk of electrical accidents. Second, it enhances reliability. Underground cables are protected from the elements, making them less likely to be damaged by storms or other events. This means fewer power outages for residents and businesses, but the benefits go beyond safety and reliability. Underground cabling also makes the city more visually appealing. No more unsightly wires cluttering the skyline. This enhances Kathmandu's beauty and preserves its unique character. Plus, it frees up valuable space above ground. This space can be used for other purposes, like planting trees, widening roads, or creating public spaces. In short, underground cabling is a win-win for Kathmandu. It's a smart investment in the city's future. To bring underground power to Kathmandu, the city embarked on several ambitious projects. Project A, one of the first major undertakings, aimed to bury cables along a busy commercial corridor. The goal was to improve reliability and beautify the area. But, like any major infrastructure project, Project A faced its share of challenges. One of the biggest hurdles was administrative delays. Obtaining permits for road closures and digging took much longer than expected. The permitting process involved multiple government agencies, each with its own set of rules and regulations. Coordinating between these agencies proved to be a nightmare. Paperwork got lost, approvals were delayed, and the project stalled. This bureaucratic maze added months to the project timeline and drove up costs. The delays also caused frustration among residents and businesses affected by the construction. It became clear that streamlining the permitting process was crucial for future projects. While Project A grappled with administrative hurdles, Project B encountered a different set of challenges: community resistance. This project focused on a residential area with narrow streets and limited access. While most residents supported the idea of underground cabling, they were concerned about the construction process. Trenchless boring, a technique that minimizes digging, was chosen to reduce disruption. However, it required specialized equipment and expertise that local contractors lacked. This led to delays in finding qualified contractors and increased costs. Moreover, some residents worried that the vibrations from the boring could damage their homes. Communication breakdowns between the project team and the community exacerbated the situation. Public meetings were poorly attended, and rumors about the project spread quickly. It became evident that building trust and addressing community concerns were essential for the project's success. Section 5. Digging deeper. Common technical snags. Beyond the administrative and social challenges, both Project A and Project B encountered common technical difficulties. Kathmandu's underground is a maze of existing infrastructure. Water pipes, sewage lines and telecommunication cables crisscross beneath the city. Accurately mapping these utilities proved difficult as existing records were often incomplete or outdated. This lack of information led to accidental damage during excavation. Another technical hurdle was the city's varied soil conditions. Kathmandu sits in a valley surrounded by hills, resulting in a mix of soil types from loose sand to hard rock. This variability made it difficult to predict how long excavation would take and what kind of shoring would be needed to prevent collapses. In some cases, unexpected soil conditions forced engineers to redesign sections of the trench, further delaying the projects. These technical challenges highlighted the need for thorough pre-construction surveys and adaptable engineering solutions. Section 6. People power, social and environmental impacts. The underground cabling projects in Kathmandu also brought to light the social and environmental impacts of such large-scale infrastructure work. Construction caused significant traffic congestion, especially in already crowded areas. Road closures and detours led to longer commute times and frustrated drivers. Businesses along the construction routes suffered from reduced foot traffic and accessibility issues. Dust and noise pollution from the construction also impacted residents' quality of life. While measures were taken to mitigate these issues, such as using water sprinklers and limiting work hours, the impacts were unavoidable. These challenges underscored the importance of effective traffic management plans and open communication with residents about potential disruptions. Section 7. Building bridges, collaboration and solutions. To overcome the delays and challenges, the project teams realized that collaboration was key. They began working more closely with government agencies to streamline the permitting process. Dedicated liaisons were appointed to facilitate communication and resolve issues quickly. For Project B, community outreach efforts were intensified. Regular meetings were held to address residents' concerns and provide updates on the project's progress. The project team also worked with local NGOs to organize awareness campaigns about the benefits of underground cabling. These efforts helped build trust and reduce opposition. On the technical side, advanced ground-penetrating radar was used to create more accurate maps of underground utilities. This minimized the risk of accidental damage and costly repairs. By embracing collaboration and proactive problem-solving, the projects began to move forward more smoothly. Section 8. Lessons learned, Project A versus Project B. Comparing the outcomes of Project A and Project B reveals valuable lessons. Project A, despite its initial delays, eventually succeeded in laying underground cables along the targeted commercial corridor. However, the administrative hurdles and cost overruns highlighted the need for a more efficient permitting system. Project B, while facing significant community resistance at the outset, demonstrated the importance of stakeholder engagement and communication. By addressing concerns proactively and building trust with residents, the project gained acceptance and was completed with minimal disruption. Both projects highlighted the critical need for accurate utility mapping and adaptable engineering solutions to deal with Kathmandu's complex underground environment. These lessons learned are invaluable for guiding future underground cabling projects in the city. Section 9. Powering up the future, a vision for Kathmandu. As Kathmandu continues to grow and modernize, underground electrical cabling will play a vital role in securing its energy future. The challenges faced by Project A and Project B provide valuable insights for improving future projects. Centralized coordination among government agencies is crucial to streamline the permitting process and avoid bureaucratic delays. Pre-construction surveys using advanced technology can help create accurate utility maps, minimizing the risk of damage and costly repairs. Community engagement from the outset is essential to build trust, address concerns, and ensure smooth project implementation. Investing in training and development for local contractors will equip them with the skills and expertise needed to handle the technical complexities of underground cabling. By embracing these solutions, Kathmandu can overcome the hidden delays that have plagued past projects and realize the full potential of a modern, reliable and safe electrical grid. The future of Kathmandu's power lies beneath the surface, waiting to be unearthed through collaboration, innovation and a commitment to progress.